Alright, so we're going to be continuing with this question. The last thing we had done was found the gradient of Cn by taking the negative reciprocal of the gradient of line AB, because we knew that the line Cn was perpendicular, which must mean that its slope is the negative reciprocal of the slope of AB. But we then have to go on and find the equation of Cn. We know then that any equation can be expressed as y equals mx plus b, and our slope we've discovered is 2. Let's substitute in a known point on the equation of Cn, like C or N. For example, the point C. I don't think actually, do we know either of the points C, N? Let me scroll up and see if we found them earlier on in the problem. There we go. Point C has got coordinates 4, 7. So let's use that point, which is on the line. Our y coordinate was 7, our x coordinate was 4, and this will enable me to solve for the value of b. So 7 is equal to 8 plus b, and when you solve for b, you'll get b is equal to negative 1. And so we can conclude then that the equation of Cn, y equals, there's my slope, 2, and my y-intercept, negative 1. And part D, we need to calculate the coordinates of n. Well, if we look at the diagram, you'll see that the coordinates of n, this is where the line Cn, if you imagined it continuing, would be intersecting with the line AB. So if we had our line AB, then we could just find the intersection of those 2 points. In fact, we were given the equation of line AB right at the beginning. X plus 2y equals 8. So let's keep this in mind. We've got 1x plus 2y equals 8 is the equation of AB. And then our equation for line Cn we discovered was y equals 2x minus 1. So y equals 2x minus 1. I'm just going to rearrange y equals 2x minus 1 into standard form so that I can use Simultaneous to find the intersection between them. And so if I bring my 2x over to the left, it becomes a negative 2x, and my negative 1 is left alone on the right. And so this is going to be the system matrix that I've got. And I'll put this thing into Simultaneous. So here we go, apps. And then go into the Simultaneous, and sorry, I've gone into the wrong one. Get out. Yes, I'm sure. Alright, try again. Apps, Simultaneous. There it is. And of course we're solving a system of simultaneous equations, so option 2. 2 equations, 2 unknowns, that's all perfect. We'll say next, and let's put in a brand new system matrix. And so we can see our coefficients. It's 1x plus 2y is equal to 8, and it's negative 2x plus 1y is equal to negative 1. And once we've entered these 6 numbers, we'll press the solve button. We'll find out that x equals 2 and y equals 3, and those will be the coordinates of point N. Finished. Number 6. We've got points P and Q that are points on the coordinate plane. We need to determine the coordinates of M at the midpoint. Well, you remember that midpoint is the average of the x coordinates and the average of the y coordinates. And so that's going to be 2 and negative 2. Finished. We need to find the gradient of the line through P and Q. We know we can do this by finding the difference in the y coordinates, 1 minus negative 5, divided by the difference between the x coordinates. So that's going to give you 1 plus 5, 6 over 4, and we can simplify this if we wanted to 3 over 2, and there's our slope. And now we have to find the gradient of the line that is perpendicular to PQ, and of course our perpendicular we know is always a negative reciprocal slope. Now it says that the perpendicular line drawn through M, where we know our midpoint M, meets the y-axis at this particular place, 0, k, and we need to find the value of k. Well, if we could simply find the equation of that perpendicular line in slope-intercept form, the y-intercept would be this place right here, 0, k. So let's just find the equation of the line, this perpendicular line. So we know that y equals mx plus b. Our perpendicular slope is negative 2/3. And so let's substitute in a known point. We know that the perpendicular line goes through M, so we've got to substitute in the xy coordinates here. So negative 2 equals negative 2/3 times 2 plus b. And now we should be able to solve for b. So we've got negative 2 is equal to, now this, it's always helpful maybe to make it a 2 over 1 to, so I can see how to multiply out the fractions. So it gives me a negative 4 over 3 plus b. And it might be helpful for me to re-express my negative 2 with a common denominator. So negative 6 over 3, that's the same thing as negative 2, isn't it? And then I'll bring my negative 4 over 3 to the left-hand side. It becomes a positive 4 over 3, and I'll discover then that b is equal to negative 2/3. That must mean then that your equation of the line is y equals mx plus b. And you will see that your b value of negative 2/3, that must be the y-intercept, right? Slope-intercept form. And so k, which is my y-intercept at point r, we can see then that k is equal to negative 2/3. Onwards to number 7. These 3 points are joined to form a triangle. We need to plot them on the grid. So the origin looks like is right here. So that's not one of my points. It's just so I can keep track of where the origin is. So A, 1, 3. So positive 1 in the x direction, 3 in the y direction. There's point A. And B is 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's point B. And point C is 7, 1, 2, 3, 4, 5, 6, 7, and negative 1. And there's point C. And so we've created a triangle. It does want us to join them to make this triangle. So there we go. And then part B of the question, it says find the distance between D and E. So what are D and E? They're the midpoints, aren't they? So let's begin by finding the midpoint of A and B. And so that's going to be then the average of the x-coordinates and the average of the y-coordinates. And so D will find out it's 5 over 2, 13 over 2. And if you like to express them as decimals, then you get 2.5 and 6.5. Let's do the same thing now for point E. And so E is going to be the midpoint between A and C. So here's E. Let's find the average of the x-coordinates and the average of the y-coordinates, A and C, 3 and negative 1. And so that gives us 4 and 1 when I'm finished. And so the question then is asking us to find the distance between the points D and E. And you remember your distance formula. We're going to take the square root, and then we've got the difference between the x-coordinates, and then we've got the difference between the y-coordinates, also squared. And so that's going to be, then I'm looking for the square root of negative 1.5 squared plus 5.5 squared. And I think I'd better reach for the calculator at this point. So let's get out of this. And so I want to find the square root of negative 1.5 squared plus 5.5 squared. And what do we get? 5.70 when I round to 3 significant figures. Alright, let's look at number 8. We've got this mapping between a whole large number of domain values, mapping to all of these y values. So it says in part A, using set notation, write down all the members of the domain of F. So I suppose one really lengthy way to do this would be to list them all individually, right? We'd have 0, -1, 1, -2, 2, -3, 3, 4, and 5. Okay? Part I, write down all members of the range. And so then we've got the values 0, 1, 4, 9, and 16. And part I, write down the equation of the function. So you might notice then that both 1 and -1 are mapping to +1. What can we do to both of these numbers to get the same result, +1? And while you're thinking about that, what would we do to 2 and to -2 in order to get 4? What does -3 do to get 9? And 3 does the same thing to get 9. Some of you might be catching on already that what we're simply doing is squaring the x values. And so what f of x is doing, it's taking the x value and squaring it. And that's how we end up getting the y value. Alright, part B. We've got the equation of a function, g of x is equal to x squared plus 1. We need to write down the range of g. So one way that we can do this is by having a look at the graph of x squared plus 1. So I'm going to go into y equals and put in the graph x squared plus 1. And I'll graph it. We end up getting this shape here. And remember that the range is all of the possible y values. And one way you can think about this is squishing our parabola down to the y-axis. So if we squish this side to the y-axis and we squish this side to the y-axis, what values on the y-axis will I have covered? Well, it will be everything from this value and higher. And this value, it turns out, is equal to 1. And so your range is going to be simply y is greater than or equal to 1. Those are all the possible y values. Let's have a look at number 9. So we've got the vertices of the quadrilateral as shown, and we need to calculate the gradient of CD. And so we know that gradient is going to be the difference between the y-coordinates, so -1 minus 1, over the difference between the x-coordinates, -1 minus -2. That gives us -2 over -1 plus 2, which is 1, and so our gradient is -2. Part B, we need to show that line AD is perpendicular. That must mean that its slope is a negative reciprocal. So let's first find the slope between A and D. Okay, so we've now got a new slope here, and it's the difference in the y-coordinates, 1 minus -1, divided by the difference between the x-coordinates, 3 minus -1. So on the top, that's 1 plus 1 is 2. On the bottom, 3 plus 1 is 4. And that simplifies to give me 1 over 2. And sure enough, -2 and +1/2 are indeed negative reciprocals of one another. Now another way that we can think about perpendicular lines, imagine two slopes that are negative reciprocals of each other, like A over B and -B over A. These are negative reciprocals, aren't they? What would happen if you multiplied two negative reciprocals? Well, A times -B gives you -AB, and B times A gives you AB. Well, look, your A and your B cancel out on the top and the bottom, and we're left with -1. This is a general property of perpendicular slopes, is that the product, or the multiplication, of two perpendicular slopes should always give you -1. So we're going to demonstrate here, then, that if we take our first slope, -2, and we multiply it by the second slope, 1 over 2, we do indeed get -1, and therefore they are perpendicular. And part C, we need to find the equation of line CD. I see that I'm running out of time, so I'll do that on the next part of this video.